holy shit, now I know why America is fat. Now I know why I don't feel good.
Without question, sugar is 80% of the story.
80% of the story.
80% of the story.
Wow.
These are the 8 things that you have to know. Number 1.
Everybody is waking up now to the dangers of ultra-processed food. But the scientist who brought us the perils of eating sugar, fructose, ultra-processed food is an endocrinologist by the name of Dr. Robert Lustig. He wrote this fabulous book called Metabolic, another New York Times bestseller called Fat Chance, and tells us exactly what we can do to preserve our bodies for the long run. And he tells us the one thing that explains 80% of how long we're going to live. I've never been more excited than this episode right now. You, in my mind, are the grandfather of processed food and what it does to us. And
okay, I don't want to be the grandfather. I can be the OG, but I don't want to be the grandfather.
You can be the OG.
That's
yes,
bad.
Grandfather's bad branding. But we're going to talk today about the problem, what our food system is doing to our body, the science of that, what it's leading to, and a solution. And you're one of the, I think, the best scientist who actually has a solution, not only for individuals, but for a system. But first, we're sitting in front of a giant bowl of M&Ms, multicolored. And I put it here.
Really big bowl.
I put it here for the irony because you've written in Metabolic about what sugar and high fructose corn syrup does to our body and the real toxin it is. And maybe it existed somewhere in science, but Metabolic, when I read this book, it's one of these books I ripped through in about a week, and it's all tattered and underlined because you do such a wonderful, clear job at explaining why we should be afraid of sugar and fructose. And can you unpack that a little bit?
In 10 words or less, sugar used to be a condiment. Now it's a diet staple. That's the problem. When sugar was something that you had after the meal, it wasn't that bad. But when it became the meal, that was where the problem was.
How much sugar does the average American eat right now?
Somewhere between 17 and 19 teaspoons of added sugar per day. Depends on which study you're reading and exactly when you're looking, but somewhere in that ballpark.
And that adds up to somewhere around 100 pounds of sugar a year, right?
Somewhere between 94 and 100 pounds of sugar per year. And the point is, our bodies were not designed for that onslaught. Our ancestors, back in the 1800s, getting fruits and vegetables out of the ground with the occasional honey, consumed about 5 pounds of sugar per year. 5 pounds. Okay, we're now up to 95 to 100 pounds. So there's been a 20 to 25-fold increase in the amount of sugar consumed. And the question is, what does that do to you? Now, if you believe that a calorie is a calorie, you'd say, well, I just cut back on other calories. So I eat more sugar, so I'll eat less fat, which of course is exactly what the food industry told us to do. Eat less fat. Well, when you take the fat out of the food, it tastes like cardboard. So what did they do? They added the sugar. Turns out a calorie is not a calorie. And where those calories come from determines where they go in the body. Now, they didn't want you to know that, because if you knew that, then you'd start asking the question, well, which calories are doing what, where, and how do I get the calories that do the most positive for me? But those are not the calories they're selling. So they don't want you to know that. They want you to think that every calorie is like every other calorie. Yeah. And that way they can say, number one, a calorie is a calorie. Number two, if if it's you eat too much, you exercise too little. Number three, diet and exercise. Number four, if you're fat, it's your fault. Number five, any calorie can be part of a balanced diet. Number six, don't pick on our calories, go pick on somebody else's calories. So this concept that calories are fungible comes from the food industry. The problem is the science has shown that this is untrue since the 1930s, but the food industry has buried that science very specifically for their own purposes.
Dr. Lustig, you are a scientist.
I am, and a clinician.
A little bit on your background.
I'm a pediatric neuroendocrinologist. I majored in nutrition in college at MIT. And then I went to medical school at Cornell, and they beat it out of me. They basically told us, this isn't how you take care of patients. Don't ask nutrition questions because that's not how you take care of patients. And, I thought, well, I'm paying big bucks to learn how to be a doctor. I'll do it the way they say. And so for the first 20 years of my practice as a pediatric endocrinologist, this whole obesity epidemic in children basically occurred on my watch. It started in around 1980, and by 2000, it was disastrous. It was
Can you
massive.
put some numbers to that disaster?
In 1980, 5% of the pediatric population was obese. By 2000, we were up to 15% above the 95th percentile, and now we are at 22% above the 95th percentile. And
So
it just keeps
almost
getting worse.
Fourfold on the way to fivefold more children suffering from obesity.
Indeed.
Since 1980, since most of us listening were around.
Right. Well, also type 2 diabetes. Type 2 diabetes was unheard of in children. Unheard of. Okay. I saw my first pediatric type 2 diabetic in 1993. And I went, what the is that? Never heard of it. I actually went into pediatrics to stay away from chronic disease. And it turned out that's all I did. Anyway, I had this idea back in 1994 when this hormone got discovered called leptin. Now, leptin is a hormone. It's made by your fat cells. It goes to your brain and says, hey, I got enough energy on board. I don't need to eat so much. I can engage in expensive metabolic processes. I can grow properly. I can engage in puberty. I can engage in pregnancy, which are all very expensive metabolic processes because I have enough fat on my bones. Okay? So the more fat you make, the more leptin you make. The leptin travels to the brain, tells the brain all is well down below.
You don't need to eat more.
You don't need to eat more, but you have enough.
Yeah.
Okay? It's like a thermostat. Okay?
Well
and the
put.
thermostat's got a floor but no ceiling. So it's not like, you go too high, but there is a floor below which, if you're below that, then your brain sees starvation. Now, this hormone leptin was discovered in 1994. Now, I knew it was coming. And the reason was because it was discovered at Rockefeller University, where I was a postdoc, and I knew all of the protagonists that were involved in that because we all had to share call at the hospital. So I knew what everybody else was doing, and so I knew this was coming. And in 1994, it did. At that point in time, I had moved to St. Jude Children's Research Hospital in Memphis, Tennessee. Because I'm a neuroendocrinologist, my bread and butter is brain tumors. Kids who, have brain tumors because that area of the brain that controls hormones called the hypothalamus, these kids have hypothalamic damage. So I'm a hypothalamus doctor. So I went to St. Jude, lived in Memphis for 6 years, where I was presented, as soon as I got there, with a cadre, a stable of 40 patients who survived their brain tumor only to become massively obese afterward, either because of the tumor itself or the radiation or the surgery or whatever it was. They were perfectly normal weight for height until the tumor, and now they're 350, 400 pounds.
And leptin is part of this?
Turns out their leptin levels were high, not low. So if their leptin is high, but they're fat, that means they can't see their leptin. They are leptin resistant. Now, there are patients who are leptin deficient who don't make leptin. There are 14 of them in the whole world. 14.
Wow.
Okay? And if you give them a shot of leptin, they stop eating and they actually lose weight and start growing properly. It's amazing for 14 people. So, of course, we tried giving leptin to standard obese people, and we tried giving leptin to patients with these brain tumors. Nothing happened. And the reason is because these other patients are leptin resistant. They have plenty of leptin. They just can't see it. They can't act on it, including these patients with brain tumors. So I was charged with trying to figure out what to do for them, and leptin wasn't it. So I knew enough about the science to know what comes after the leptin, and that is the leptin tells a nerve in your brain called the vagus nerve, longest nerve in your body, that you need to release more insulin. So there's a pathway straight from the brain down to the pancreas, the pancreatic branch of the vagus nerve. And if you cut the vagus nerve, then it doesn't happen. Now, I'm not a surgeon. I can't cut a vagus nerve. Could I do the equivalent? Well, there's a medicine that can basically knock insulin down at the beta cell. Okay, and it's a medicine that endocrinologists know how to use. It's called octreotide. Normally, it's used to suppress growth hormone. I used it because it also suppresses insulin. So we did a pilot trial of octreotide in these kids at St. Jude who had obesity due to brain tumors. And lo and behold, they started losing weight. But something even more remarkable happened, Dan. The parents would come back to me at the first visit after starting the medicine. And they said, I've got my kid back. These were kids who sat on the couch, ate Doritos, and slept. They had lost all interest in the world around them. Okay? They, used to play with other kids. Now all they do is basically sit on the couch and watch TV, or back then, video games were just coming up. Okay? Bottom line, they were now active. One kid became a competitive swimmer. 2 kids started lifting weights at home. 1 kid became the manager of his high school basketball team, running around collecting all the basketballs. These were kids who did nothing. And the kids would say things like, this is the first time my head hasn't been in the clouds since the tumor. This is really remarkable. So we did a second study, a double-blind placebo-controlled trial of 20 kids. And this time we built a quality of life questionnaire into the study.
Smart.
And it turned out, when it was all said and done, the exact same thing happened. And we showed that physical activity went up. Physical activity went up. So if you're losing weight and your physical activity is going up, that means that you are now leptin sensitive. That means you are actually burning energy faster because your leptin is working. So we turned these kids around and we changed their behaviors because they stopped eating and they started exercising, all because we got their insulin down with this medicine. So what this demonstrated to me was that the behaviors that we associate with obesity, the gluttony and the sloth, the it's your fault, turns out that's completely untrue. In fact, the biochemistry drives the behavior. And when you fix the biochemistry, you fix the behavior. Okay, so then we said, all right, this is really cool. Could this be true for garden variety adult obesity without brain tumors?
Yeah.
So what we learned was insulin's the bad guy. And we learned that in 1999, we learned that. And here we are in 2026. And all the data that's come in since then has only supported that. Insulin's the bad guy. You got to get the insulin down any way you can.
So narrate for us. We just had a big bowl of M&Ms on there, and we don't have to pick on M&Ms, but just high sugar.
Yeah.
From the time I put it in my mouth to the journey down through the digestive tract,
Right.
what does our body do with that excess sugar?
Well, let's start at the mouth.
Okay.
Okay. Actually, let's even start before the mouth.
All right.
Okay. Let's start before the mouth. Let's start with just looking at all those colors. Okay.
Yum.
Famous study done by Terry Powley back in the early 1980s. They took a bunch of normal adults and admitted them to the hospital, put an IV overnight, woke up the next morning, they're fasting. Their insulin levels are low. Okay? They brought a plate of food into the room. Okay? Breakfast. But they didn't let them eat it. They just looked at it. They just smelled it. And then they took the plate of food out.
Insulin levels.
The glucose level stayed the same. The insulin levels went up. And the more obese they were, the more they went up.
Wow. And the insulin is basically telling you to eat.
That's right. The insulin's basically saying, I'm shunting energy to fat, so I need to eat to make up the difference. That's exactly what it's telling you. So this is called the cephalic or head phase of insulin release. Okay? Well known. And in fact, that's what these kids had, was they had an accentuated, augmented cephalic phase of insulin release.
So we look at those colorful, beautiful M&Ms, and our insulin's probably going up. And then we put a couple in our mouth and then chew it, and we get that first burst of flavor.
Then, because you get that first burst of flavor, message goes via the trigeminal nerve from the tongue up to the brain. Sugar's here. And it goes to the nucleus accumbens, the reward center. And it goes,
you gave me what I wanted.
Haters. And so what that does is that says, this feels good. I want more. Because that nucleus accumbens, that reward center is, it's responding to the dopamine rise that came from that.
Very similar to
sugar.
Cocaine, right?
Exactly the same as cocaine.
Remember that, Mom, when you give your kid candy.
No different. It's exactly right. All right. So you've got that going for you. Now, you start salivating, and the saliva starts cutting carbohydrate, starch, into individual glucose molecules. So you already have some glucose that's going to get absorbed really fast because you're already working on metabolizing it, on digesting it and metabolizing it, just due to the saliva.
And glucose is a very simple sugar. They shunt it into our cells.
Right. Glucose can go into every cell in the body. Certain cells need insulin to get the glucose in. Certain cells don't need the insulin to get the glucose in. Depends on which cell.
So now we're about to swallow. And
right.
We've chewed, saliva cut the glucose.
Right.
Then what happens?
Okay, so it goes down into your stomach, and the stomach then releases a bunch of enzymes to chop up proteins if they're there. Okay, and it releases acid in order to help make those enzymes, cut up the proteins and the fats even better. And then there's a valve at the end of the stomach called the pylorus, and it opens quick, then closes, and opens quick, and closes. And so a little bit of food will go down through the pylorus into the duodenum. That's the first part of the small intestine. And if the carbohydrates have been chopped up into little pieces, they can get absorbed there. And so you will start having a glucose rise. Well, if it was sugar, because sugar is glucose and fructose, the sweet molecule in sugar, you will get a fructose rise too. Now, the glucose goes everywhere. Glucose goes to the entire body. The fructose goes to the liver. And the liver has a limited capacity to metabolize that fructose. In the same way, it has a limited capacity to metabolize another substrate called alcohol. So if you drink a little alcohol, your liver gets it and your brain doesn't because your liver cleared it. If you drink a little more alcohol, you overwhelm your liver's capacity to extract the alcohol, and some of it will reach your brain. And so you get a little tipsy. And then you have another drink and a level will go a little higher, and you'll get tipsier, and soon you're flat on the floor.
But what happens?
Fructose does not do that.
Yeah. So let's just say it's a Coke, that's
right.
high in high fructose corn syrup, and
right.
now we've overloaded very quickly our liver of fructose. What is our body?
So our liver is going to turn all that fructose into fat, and then some of the fructose will have made it past the liver, and it will go to all different parts of the body. And what it does in different parts of the body depends on that part. At the pancreas, it will release more insulin. So fructose will drive insulin release at the pancreas. So that's bad because that's going to drive more energy into fat. At the brain, the fructose actually gets taken up by glial cells, and that actually prevents glutamate, which is a excitatory neurotransmitter, from being converted into GABA, which is an inhibitory neurotransmitter.
Simplify that for me.
So glutamate is what makes you irritable. GABA is what makes you serene. And glutamate gets turned into GABA. And there's an enzyme called glutamine synthase that's necessary to accomplish that. Fructose inhibits that enzyme.
Oh,
So you
wow.
get lots of glutamate and no GABA.
Yeah. So you get ornery and
You get ornery and nasty and, sugar high.
Oh, that's a sugar high.
It's a sugar high.
In my travels to the world's blue zones, I've seen that the longest lived people don't just have healthy diets. They have a clear sense of purpose. They know why they wake up in the morning. And that's why I appreciate the perspective of Thrivent. They're a financial services company that believes money is a tool, not a goal. Through purpose-based advice, investments, insurance, banking, and generosity programs, Thrivent can help you create a financial plan that reflects your deepest values. It's about more than just a bank account. It's about supporting the people and causes you love. With over 120 years of experience, Thrivent is a Fortune 500 company that actually puts generosity at the heart of what they do. When your finances align with your purpose, you're not just planning for the future, you're living a life that means more. Learn more at Thrivent.com. And more or less, let's take in terms of a Coke, a 12-ounce Coke. How much can you drink of that can of Coke for the average 10-year-old before it's too much for your liver?
8 ounces for the average 10-year-old.
8 ounces.
That's the entire fructose allotment for the day. An 8-ounce Coke. And that's just the 8-ounce Coke, never mind the rest of the diet. If you go to Trader Joe's and you order, and get their beef with broccoli, that's got 32 grams of sugar.
It's
so
all
16
over,
grams
isn't
of fructose. Yeah. And that's dinner. So I am here to tell you and your audience, okay, I am not the sugar Nazi. I am for dessert. I am for dessert. How's that?
We love you.
For dessert. I am not for dessert for breakfast, lunch, snacks, and dinner.
And most breakfasts, like I grew up eating Captain Crunch, Lucky Charms.
Me too.
And now we find out
look at us.
Yeah. Beware, moms. But they were essentially sugar, weren't they? And,
oh, absolutely. So you remember Honey Smacks?
Yeah.
Kellogg Sugar Smacks?
Loved them.
56% sugar. That's why they melted in the bowl.
Oh, my God.
Okay. Fruit Loops, okay, is the standard national school breakfast program breakfast. And we'll get to those breakfasts in a minute, okay? But they're 41.4% sugar. They're number 10 on the list. And they're the national school breakfast program breakfast.
So wrong.
That's 12 grams of sugar. And then put on top of that a glass of orange juice, because that is a standard national school breakfast program breakfast. A bowl of Fruit Loops and a glass of orange juice.
Which is full of fructose.
Full of it. That is 41 grams of sugar. That is over triple the dose that's too much, over the limit. And it's just breakfast.
So people listening here, for the average adult, how much sugar can you have in a day where it's probably not a problem?
If you're an adult, under 25 grams of sugar, added sugar.
And give us some examples of what 25.
6 teaspoons of added sugar.
So that's maybe a candy bar?
Depends on which candy bar.
Uh-huh.
But I would, basically it's an 8-ounce Coke.
How about a piece of chocolate cake or something?
Piece of chocolate cake would have anywhere from 20 to 30, depending on the recipe.
Okay. And how about for a kid? I have a 10-year-old kid. What's the safe amount for? So
the American Heart Association says that for adolescents, it's the same as adults, so 6 teaspoons. For kids below adolescence, so basically 5 to 12, we say 3 teaspoons of added sugar per day. That's 12 grams of added sugar per day. Per day, not for meal, per day. And then below 5, so 2 to 5 is 2 teaspoons of added sugar per day, and below age 2, 0.
Wow.
0. American Heart Association.
What happens if I give my and I've seen this, by the way, mothers putting Coke in a baby bottle and giving it to their 2-year-old.
Yeah.
What am I setting that child up for the long run?
Well, first thing is tooth decay. Let's be very clear. Sugar is the cause of tooth decay. People say, oh, starch causes tooth decay. No, it doesn't actually. Starch actually protects against tooth decay, forms what's known as a biofilm, because starch is not fermentable. So the thing that makes the hole in the tooth is the lactic acid. So you have to ferment the sugar in the mouth to lactic acid to burn the hole in the tooth. Starch doesn't ferment, but sugar, as soon as you've cleaved it into its individual fragments, it's fermentable. So glucose is fermentable, fructose is fermentable, sucrose is not fermentable. Okay, until you cleave it, and then it is.
Okay.
Okay, so fructose is the driver.
But it doesn't it sort of predispose you for obesity if you're giving your little baby
Absolutely.
even orange juice in a bottle, or
Absolutely.
apple juice, Gerber sells you apple juice in the little.
What you're doing is you're taking that fructose and it's being delivered straight to the liver. The liver can't handle the load, and the liver is diverting that fructose load to be converted to fat for storage.
But what does it set the child up for as an adult?
Well, it's gonna set them up for fatty liver disease. It's gonna set them up for type 2 diabetes. It's gonna set them up for hypertension. It's gonna set them up for obstructive sleep apnea.
Even though that doesn't happen for 30 years or 40?
It's still setting them up for it.
Why? How?
Because of the fat that's being laid down in the larynx. Okay, that's going to basically press on the sides of the airway so that you end up with obstruction.
So obesity starts as a child, as a baby.
Obesity actually starts in the womb. It starts before you're ever out, and I can prove it. 4 studies, Israel, South Africa, Russia, United States, looking at birth weight over the last 25 years. Turns out every single one of those countries has had a 200-gram, half a pound increase in mean birth weight, over the last 25 years. So you'd say, well, that's good. They're healthier, right?
Yeah.
Well, if you stick those kids in a DEXA scanner,
which measures body fat,
turns out those 200 grams are all fat. So we have obese newborns.
Jesus.
They don't diet and exercise. So any hypothesis that you want to proffer to me about what causes the obesity epidemic in the United States, you have to be able to explain that, and you can't. Because this is actually going on even before the baby is born.
And it's probably because the mom is eating too much sugar and ultra-processed food.
Almost assuredly, yes.
And the child comes out overweight, and it's probably hard to get rid of that fat throughout life. But They probably have a taste for rich foods and
yes,
sweets.
Absolutely. It changes the taste receptors, so they gravitate towards sweet. Here's another example that came out just last year about how important what goes on before birth is. Study out of the UK. Sugar was rationed during World War II. And it remained rationed during World War II all the way up till 1953.
Do you remember how much people got?
Well, it was about a 25% reduction over what they were consuming. I don't know.
And they were probably eating a lot less than we were to begin with.
Probably. But 25% reduction. But then in 1953, Parliament passed a law that basically said the rationing was over. So you have babies born in the UK before 1953 during sugar rationing, and babies born after 1953 when the sugar rationing was ended. A group in London has studied what has happened to those babies now that they are old enough to actually get sick and die, okay? Because they're all now 70, right?
Mm-hmm.
Turns out the babies born after 1953 have double the rate of heart disease, hypertension, and fatty liver.
That's amazing.
As does the group that was born before rationing ended.
I mean, that offers itself as a very clear sort of policy idea if a country really cares about making people healthier. Ration sugar.
We don't have to ration it. We just have to get it out of the foods that never had it before, but now have it because the food industry put it there. That's what I'm upset about. This is why I meant by I'm for dessert. I'm just not for dessert for breakfast, lunch, snacks, and dinner. It's the sugar in the salad dressing. It's the sugar in the ketchup. It's the sugar in the yogurt. It's the sugar in the bread. It's the sugar in, virtually everything that you didn't know had it. Okay. I know about candy cakes, ice cream. I know about beverages. Okay. Half of the sugar that we consume is in foods we didn't know had it.
Oh my God.
That's what we need to fix.
What's the most insidious example of
yogurt?
Yogurt.
Really?
Everybody
says yogurt's healthy.
It's got active cultures.
Crapola. Actually, they're all dead, number one. Number two, if you buy a plain yogurt, okay, standard, Dannon yogurt, single pack, right? It will say on it a number of grams of sugar, 7. And all of that is lactose. That's milk sugar. And that's perfectly fine. That's not a problem. Now take a look at the strawberry yogurt, the same size, 23 grams. So 16 grams of added sugar in that strawberry yogurt. Why? Very simple. Hate to tell you, but yogurt's sour.
Oh, it overcomes the...
It overcomes the sour. It overcomes everything. So sweet overcomes bitter, it overcomes sour, it overcomes salty, it overcomes umami. It overcomes all the other tastes. Bottom line is you can make dog food taste good with enough sugar. And they do.
And we eat that and ding, 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 the part of our brain that registers reward is going off and says, give me more.
Give me more.
And the more we eat, the more we overload our liver, the more...
The higher our insulin go and the more we eat. And that's the vicious cycle.
And what are some of the ways that we accelerate our aging by eating too much sugar?
In Metabolical, I talk about the 8. So, by the way, sugar is the aging nutrient.
Yeah.
So if you can call it a nutrient.
Anti-aging.
Right. Well, cutting back on sugar is the best way to improve aging at every level.
Wow.
At every level. Okay, and we have the data for that, slam dunk.
I just want to underscore that for people. So we spend $84 billion a year on anti-aging nostrums, and yet the most powerful thing we can do to slow down our aging process is probably cut out sugar.
Yeah.
For most Americans.
That's the big kahuna. That's the 2,000-pound gorilla in the room. Are there other things you can do? Sure, absolutely. Yeah. Should we be doing them? Yeah, I'm for them too. Okay, but without question, sugar's 80% of the story.
80% of the story.
80% of the story.
Wow, that's a headline right there. I'm 43 episodes looking for the answer to slow down your aging. Cutting out sugar
is 80%.
80% of it. That's huge.
There's more, but that's the big kahuna.
What are some of the triggers, or what are these 8 pathways that you talk about?
All right. Well, we're going to have to use some fancy words here.
Yeah, but pretend I'm your 15-year-old.
Let's do it with an analogy.
Okay.
Cars.
Okay.
There are 8 subcellular pathologies that are going on inside all of us all the time that are contributing to the aging process. 8. And we can liken them to individual things that go on inside cars. Okay? Ultimately, here's how to think of it. You, Dan Buettner, were born, however many years ago you were born, with a bright, shiny, spanking, brand new cherry red Corvette. Okay? Your job over this life was to keep that Corvette in tip-top running condition, lest it be converted into a moth-eaten jalopy. The problem is you have to do it without a warranty and without an owner's manual.
And that's the situation most of us are in.
That's exactly the situation all of us are in. So the question is, how do you do it? How do you do it? So what's the owner's manual? Well, these are the 8 things that you have to know. Number 1, glycation.
This is an interesting one.
Okay.
Kind of the
Glucose is
browning.
binding. It's the browning reaction. Okay. It's the reason bananas brown. It's the reason we paint, barbecue sauce on our ribs before grilling them to get that caramel color. Well, we're all browning. We're browning all the time.
But what happens when you brown? It's a combination of sugar, right? And protein.
It's sugar binding to a protein.
Yeah.
And what it does is it makes that protein less flexible.
Our muscles, for example?
Yes. Okay. And all of your, proteins in your kidney and proteins in your pancreas and all sorts of proteins all over your body are now less flexible, not doing their job like they should. And every time that occurs, every time that reaction occurs, the glucose or the fructose binding to a protein, you're giving off a little oxygen radical, a little reactive oxygen species, a little hydrogen peroxide.
Yeah, a rusting agent. Sort of.
A rusting agent, yeah. In essence, yes. I mean, so hydrogen peroxide is good on a wound. How would you like hydrogen peroxide running through your bloodstream?
Yeah.
Not so good.
Caustic, yeah. It's,
a little caustic.
And just to be clear, we've eaten a little bit too much sugar, and we have this excess glucose. It is circulating through our bodies. It binds to protein, which is a muscle, for example. Does this explain why older people are less flexible?
There are a bunch of reasons why. That's one of them. It's not the only reason. There are others too.
But over time, it makes our muscles kind of browns them. And
yeah, well, it also puts fat in the muscles. And that makes them work less well too.
Okay. So, and number two, we have this corrosive.
So rusting, basically oxidative stress.
Yep. Number three.
And and it's the rusting of the chassis and also the engine. Number three is mitochondrial dysfunction. So mitochondria, everyone heard the word because you took biology in 10th grade.
They're the little factories in our cells that
right. The little energy burning factories. Now it turns out they do a whole bunch of things. They do about 9 or 10 different things. But the main thing they do is that's where you take food energy and convert it to chemical energy called ATP that your cells can use to power themselves. Because everything that your cell does requires energy. Everything. And it's got to come from somewhere. Well, it comes from your food, but through ATP. So the mitochondria have to turn the food into the ATP. When the mitochondria don't work well, then you can't do that. Well, it turns out the worst mitochondrial toxin is fructose. There are others, but that's the worst one.
So the upshot of that is the engines that give us energy are gunked up.
That's right.
Don't work as well, so we have less energy.
Well, unfortunately, the candy bar industry tells you that all of those
energy bars,
protein bars, power bars are giving you ready energy. Actually, they're sapping your energy.
Wow. You get a little sugar buzz, and then in the long run, this is going to make your mitochondria work less well over time. Does this happen quickly, or does it take decades?
It does not happen quickly. It happens in 2 weeks.
Really? And is it permanent? Is it reversible?
It is very reversible.
So stop eating too much candy and your energy comes back.
Absolutely.
I think that's another thing to underscore with people because so many people are looking for more energy.
Yep. And they're only making things worse. Sugar is the sapper of energy.
That's a big one.
And by the way, there is a convenience store within 500 feet of every school in the United States on purpose.
Within 500 feet?
Because the kid is a target.
Well, we all are, aren't we?
Well, yes, we are the targets.
These are so interesting. So sugar is rusts us from the inside out.
Yep.
It makes us stiff in some ways.
Yep.
It saps our energy.
Yep.
What else? What are the other wonderful things?
Number 4, insulin resistance. So we talked about the high insulin levels because the insulin's basically taking the energy out of your bloodstream and throwing it into fat cells. So that's a big problem. And, when your insulin's not working right, your cells aren't working right.
And diabetes.
Diabetes, right? And also, when your insulin's high, it causes glandular tissue to grow, and that's what leads to glandular cancers. What do you think
breast
causes
cancer, for example?
Pancreatic cancer, yeah.
Wow, that's
prostate, yeah.
Very hard to beat that.
Yep.
Really? So sugar
Sugar
is connected to pancreatic cancer?
Absolutely.
How come I don't see on the label of a candy bar that this product increases my chances of pancreatic cancer.
Talk to RFK Jr. about that.
All right, I don't want to just derail us anymore. Okay, keep going.
Number 5, okay, membrane instability. Now, this one is not actually due to sugar. This one's due to funky fats, especially trans fats. So think of it this way. Membrane fluidity. You have a balloon, okay? And you play with the balloon. It's not blown up yet. Play with the balloon, you stretch it, it stretches fine. You blow it up, right? And you can push on it and it's all fine. And if you put a pin in it, it'll pop.
Yeah.
Okay, great. Now take another balloon, blow it up, same way. Put it in the corner of your bedroom for 3 weeks. What's going to happen?
Deflates.
It's going to deflate. Now undo the knot, blow it up again. The tension, the texture of that rubber has changed.
Yeah, it's weaker.
It's weaker. You could actually puncture that balloon with your fingernail. You don't need a pin to do it. Okay? It is now more fragile, and it doesn't blow up the same as it did before. That's membrane instability. That's what's happening to your neurons. And the fat in your neurons, in the membranes of your neurons, are what protect it from that happening.
So this is the result of eating things like palm oil or hydrogenated palm oil.
Well, in particular, trans fats.
Yeah, which is
palm oil may not be as bad as all that. It might actually be omega-6s that are worse, the seed oils.
There's this sort of obsession with the dangers of seed oil. And, olive oil technically is a seed oil.
Well, technically, yes.
Well, but what seed oils are okay, medium, and bad?
So I think seed oils have actually gotten a bad rap. Okay. I don't think they're as bad as people say they are. If they're in the right venue, at the right time, in the right amount,
okay,
they're okay, except for trans fats. They're never okay. But the others can be okay in certain places.
Just to be clear with people who may not know what a trans fat is, where do trans fats mostly show up in our diet?
Oh, they're in baked goods and ultra-processed foods. The way you know that they're there is on the label, on the ingredients, it will say mono and diglycidyl esters. That's code for trans fats.
Okay.
They are the worst. And the reason they're put there is because bacteria can't digest them. So they keep the food from going rancid. So they increase shelf life. Now, the reason the bacteria can't digest them is because the bacteria don't have the enzyme to cleave the trans double bond.
All right.
Well, guess what? Our mitochondria are really repurposed bacteria. We don't have that enzyme to cleave that trans double bond either. So when we consume them, they line our arteries, they line our livers, they never go away.
Never?
Never. They're there forever. They are the original forever chemical.
So if you're eating Doritos your whole life, you're going to be riddled with
trans fats.
Wow. And these destroy the integrity of membranes in our bodies.
Exactly right. So that's why trans fats are truly the devil incarnate. Okay. Thing is, it took us 57 years to learn that lesson. It wasn't until 2006 that the FDA actually said, we need to do something about these.
And some seed oil is good because it fuels some inflammation, which we need to fight infection, but too much.
Too much. And right now we're too much. Everyone in America is inflamed. 93% of America is inflamed.
And it's not because we're pouring seed oil all over our food. It's because it's in so many processed foods.
Correct.
Yes.
That's right.
So just a quick takeaway for people. What are, in general, good oils to cook with and bad oils to cook with?
So this is very complicated. I'll do my best. The goal is to use oils that have a high smoking point and that have 1 or 2 double bonds. High smoking point and 1 or 2 double bonds.
So is that avocado oil or?
Avocado oil is one of them, yes. What about olive oil? Olive oil has 1 double bond, which is good, but it's got a very low smoking point. So people do not fry in olive oil. If you fry in olive oil, you're wasting your money and you're actually creating trans fat. So not so good. Olive oil is meant to be consumed at room temperature. It's great for salad dressing.
Yeah.
But sautéing in it is a question mark, and frying in it is a disaster.
Interesting.
Okay. Sesame oil is pretty good. Okay. That's also got 2 double bonds and has a high smoking point. That's why they can use it in woks. Okay. Because that's a very high temperature. The ones that you have to be, most, and by the way, saturated fat, beef, lard, beef tallow, the RFK beef tallow thing. Turns out there's no double bond to flip. So in fact, saturated fat is not that bad. It's not good, but it's not that bad. And it's actually very good to cook in. Now, here's the problem with saturated fat. There's not one. There's 2. We glom them together like they're the same thing. And they're not. There's red meat saturated fat. There's dairy saturated fat. They are not the same.
Is that right? That's interesting.
They are not the same. Red meat saturated fat is C16 or C18, no double bonds. So palmitic or stearic acid. Cardiovascularly, the data say that those are cardiovascularly neutral. They're not good, they're not bad. Everyone wants to blame saturated fat. The reason they want to do that is because they say red meat is associated with diabetes and heart disease. It's probably not the saturated fat. It's probably the iron, which is an oxidative stress. It's probably the choline, okay, which is in muscle.
Yeah, which a lot of people take as a supplement.
Well, yes, but if you overdo it, it gets turned in the gut into trimethylamine, which then goes to the liver, gets turned into trimethylamine oxide, which is the stickiest substance your body makes, and it lines your livers and your arteries and causes heart disease. This is the work of Stanley Hazen from the Cleveland Clinic. Okay? So it's probably those things that are the reason red meat is associated with these diseases. But in fact, the hazard risk ratio for red meat and heart disease is actually 1.25. And if you factor out the...
I don't know what that means.
It means if you eat a lot of red meat, you have a 25% increased risk.
Okay, of dying early.
Of getting a heart attack.
Okay.
But turns out when you remove the iron and the TMAO from the equation, turns out the hazard risk ratio is down to 1.12. So only 12% increased risk, which is like nothing. And that we don't even talk about those.
I'll tell you something you might find interesting. I happen to know the person who ran Ancel Keys' lab. He's still alive. His name is Henry Blackburn.
Okay.
He's over 100 right now.
Okay.
I see him regularly.
All right.
And he told me that Ancel Keys, Ancel Keys discovered or identified the Mediterranean diet. And he followed populations from as far north in Finland to as far south as Corfu, and tracked what they ate. And he noticed that the places where people ate a lot of fruits and vegetables and nuts and beans, a little bit of wine, a little bit of fish, they were less likely to die in the next 5 years than the people up north in Finland that were eating lots of meat, cheese, and eggs.
Right.
And his brood observation was the more animal protein, a higher mortality or the better chance, brood observation.
Yeah.
But you couldn't publish a paper back then. So he's the one who made this sort of theory that it was saturated fat leading to high cholesterol, leading to cardiovascular disease.
Yeah, and that ain't it. And that ain't it. In fact, that's not the case.
And what is the case?
And first of all, the other thing you need to know about Ancel Keys is, he published his seminal tome in 1971, the 7 countries study. It wasn't 7 countries.
It
was 23.
Yeah.
22 countries. He left 15 countries out. How come? Because they didn't fit the curve. And actually, if you look at the 7 countries, they are US, UK, Australia, Japan, Italy, I'm missing 2.
Finland, North Korea?
Yeah, I think so. Finland, I think, is in there. And one more. Can't remember. Okay, if you line them up, okay, and he says, yeah, saturated fat, mortality from heart disease. Okay, turns out Japan and Italy are at the bottom of that list. They don't eat sugar. They didn't eat sugar either. So the ones down top, they're eating saturated fat. They're also eating huge amounts of sugar.
Oh, you forgot to look at sugar.
In other words, it's not the animal. It's not the meat. It's the donuts. So I am actually an Ancel Keys antagonist. I think he got it wrong. And I think that we have the data to demonstrate that he got it wrong. I am for the Mediterranean diet, by the way. That's actually one of the good diets. I'm not for one diet or another diet. I think there are a lot of ways to skin this cat. Okay, there are plenty of countries that don't follow a Mediterranean diet and who are doing just fine. So it's not like you have to do one diet.
Yeah, Southeast Asia does, right?
All the diets that work all over the world are low oxidative stress diets, low reactive oxygen species diets.
And what is that?
In other words, low sugar and high fiber. Low sugar, high fiber diets work everywhere. And what is a low sugar, high fiber diet called? Real food.
Here's something odd. The idea of health adjusted life expectancy or health span.
Mm-hmm.
The countries around the world and subregions with the highest healthy life expectancy, 15 of the top 15 are in Southeast Asia.
Mm-hmm.
And what's their staple food in every one of them?
Rice.
That's right.
Yeah.
And rice is maligned all the time as this high glycemic food.
I understand.
Should we be maligning rice?
Well, so it depends. It depends what the rice is going with. And it also depends on whether it's brown rice or white rice.
It's always white rice.
Yeah, it is. I understand that. they do like their white rice. What else are they eating?
Vegetables.
They're eating fermented vegetables. That's what they're eating. They're eating rice and fermented vegetables and a little bit of fish. That's what they're eating. They're getting their omega-3s from the fish. They're getting their fiber and also all sorts of micronutrients that are important from the vegetables. Because they're fermented vegetables,
which is pickled, usually.
Pickled, which gives them the butyrate, the short-chain fatty acids, which are anti-inflammatory, right? And then the rice is sort of like, so what?
It's the vehicle.
It's the vehicle.
Delivery vehicle.
Exactly right. So yeah. I have no problem when that's what the diet looks like. The problem is that when you combine the rice with butter and sugar and call it Jewish rice pudding at the delicatessen, that's not exactly the same thing.
Or that orange chicken that the Chinese restaurant, they're chicken's dipped in batter and then fried and then coated with a kind of a sugary orange.
Yep, that's the problem.
And then you put on rice, you got a problem.
Well, that's 32 grams.
So we got to this sort of membrane.
Right. So we got up to 5. Right. Number 6 is inflammation, and the inflammation is made worse by the sugar, of course, but also by trans fats and the lack of butyrate. And so fiber is super important in terms of the suppression of the inflammation. Number 7. Okay, remember there were 8.
Yep.
Okay, number 7, methylation. So methylation. Methyl groups get put onto both DNA and to proteins. The more methyl groups get put on, the older your cells. This is one of the things that people look at in terms of epigenetic age and this new concept of biologic clocks is how many methyl groups get put on.
What does a methyl group look like?
A little CH3. It's basically, you can't see them, but they get put on.
But molecules sort of glom on.
And what it does is it changes protein synthesis. And so it alters cellular function. It alters cellular survival. So the more methyl groups, the bigger the problem. So what prevents that? B vitamins. Okay, B vitamins, pretty much all the B vitamins, in particular folate.
And if they've accumulated there, can you get rid of them by taking lots of vitamin B?
That's a good question. And the answer is you can, but not great.
Okay.
Better for them not to have occurred in the first place. It's hard to get rid of them once they've occurred. And the other bad thing about it is they actually are transmitted to the offspring. So you basically are suffering from your mother's methylation, and she's suffering from her mother's methylation, and it's going on for generations at a time.
And the methylation, they sort of govern how the genes express themselves.
Exactly right. That's right.
So it's a flawed piece of code that you're inheriting from your mother.
In essence, without changing the DNA sequence, you're still changing the DNA expression.
Yeah.
That's right. So that's a big problem, methylation. And then finally, number 8, my favorite, autophagy. So what does that mean? Auto, self, phagy, eating, self-eating. In fact, you make crap inside every one of your cells every single day. You make all sorts of junk. Mitochondria go bad. You have stuff you have to get rid of in order to make room for new stuff to come in.
Or you just don't want to build up a garbage in your...
Right. It's like loading up your refrigerator, okay? At some point, you got to throw out the stuff that went rotten in order to be able to put new stuff in, right? So autophagy is garbage night for the cell, okay? You do it once a week at your house, okay? You do it once a day in your brain.
Sugar impedes that garbage collection?
Absolutely. Sugar impedes.
How's that?
So sugar, by changing those proteins, by making them less flexible, okay, they can't help clear the way that they should. They are actually impervious to clearing.
We had Walter Longo in here, who's a fasting or fast mimicking expert.
And that's what autophagy is for. And that's what intermittent fasting is for, is to increase autophagy.
And it really does work.
It works, yes, absolutely. There are many studies around the world showing that the people who who engage in intermittent fasting live longer and are healthier. I agree with that. The question is, are there studies that show that if you take someone who's sick in America and you give them an intermittent fasting or a time-restricted eating diet, will it make them better? And the answer to that is some of the studies say yes and some of the studies say no.
I suppose if you don't eat for 12 hours and then load up on McDonald's burgers and a Coke and a shake, it's
going to have limited utility.
You know, this Mark Mattson, who
know him well at Hopkins.
Yeah, he asserts that the way to do intermittent fasting is no food as soon as you wake up. Evolutionarily, that was probably humans didn't toddle over to the refrigerator.
Yeah.
And first meal of the day is at noon, and then essentially eat a blue zone diet, which is largely whole food, largely plant-based with some meat.
And that'll work. And I have nothing bad to say about that. That is perfectly fine. So those 8 subcellular pathologies, I call them the hateful or grateful 8. If you're doing them right, you'll be 110 playing tennis. If you're doing them wrong, you'll be 40 on a gurney in your emergency room with 2 stumps on dialysis waiting for your next dose of TPA to unblock your arteries.
By the way, if you want to read one book to understand what ultra-processed food is doing and sugar is doing to your body, Metabolical is it. And it's, by the way, he does have some technical graphs and words in there, but it's consummately readable. And
I appreciate that.
Yeah.
Listen, I got to tell you, when I wrote this book, the publisher told me, "You're publishing this for the public." And I said in my head, "No, I'm publishing this for the doctors." I needed to put enough medical information in this book so that doctors would understand it and would agree with it. And in fact, they have. This book Metabolical, is now a textbook for several medical schools.
But you can read it. You don't need a medical degree to read it. I mean, you do. Yes, there's some technical words in it, but the illustrations and the anecdotes that you say are constantly readable. And you read this book and you say, "Holy shit! Now I know why America is fat.
Yeah.
Now I know why I don't feel good." And it is absolutely a transcendent, transformative book. And you'll see. It's for those of you who are watching us on YouTube. This book is full of places where I marked it up and made notes. And that's those are books I really love.
Oh, thank you, Dan.
Be sure to come back for part 2 of this conversation with Dr. Robert Lustig.
Get rid of the subsidies. Corn, wheat, soy, sugar, everything that's killing us.
And
why in the world would you subsidize the thing that's killing you? Answer, very simple, profit. So it's basically their profit against our health.
Unbelievable.